Hello students, welcome back. So now I will show you how you can detect outliers using standard deviation or z-score. Both these methods, they essentially lead to the same result. Your answer would be same. So I import my necessary libraries, read the CSV file. So in this CSV file, it contains information about CGPA, marks, and about students. So the two important columns that we'll be focusing on would be CGPA and marks column. So I want to see how many rows and columns I have. So I do df.shape and that gives me 1000 rows and 3 columns. So let's plot this. I want to see the histogram. I want to see how exactly it looks like. So I want to plot the histogram for CGPA column and also for the marks. So I plot the histogram, and you can see that your CGPA, it actually has a normal distribution. On the other hand, your marks column, that particular feature, it is not normal. It is actually skewed to the right. Now, if you recall from my previous class, I explained that if you want to find outliers using standard deviation or z-score, they're only applicable if your distribution is normal. That would be for this case right here. So in this case, this is only applicable to this CGPA column. So we're only going to be applying this to the CGPA column. Okay, so let's find the minimum value of my CGPA column. This actually calculates the minimum and also the maximum. I also want to know my mean and standard deviation. So these are my corresponding stats for that. You can see that the mean value for CGPA is 6.9. That would be, yeah, somewhere over here. 6.9 would be somewhere over here. So if any value is very far from 6.9, okay, any value that actually is on this side, extreme on this side, or extreme on this side, that would be my outlier points. So now I'm going to be using standard deviation to find outliers. So in order to do that, you have to know your mean and standard deviation and everything. So in order to calculate the mean of your of that column CGP, you just call a mean inbuilt method, and that's going to calculate your mean. Likewise, you can calculate your standard deviation by calling your inbuilt method STD, and this is short for standard deviation. So my lowest limit, that is my lower limit, is going to be mean minus 3 times sigma. I'm using this as my lower limit, and my upper limit is going to be your average value plus 3 times of your standard deviation. So after I do this thing, I calculate my lowest and upper limit, comes out to be 5.1 and 8.80. So any value that we are basically, I'm just saying that any value that falls outside this range, that would be my outlier point. So if you come back over here, so 5.1 would be somewhere over here, and 8.8 would be somewhere over here. So any value that falls on this side and this side, these are my outliers. Okay, so now I have my upper and lower boundary. So let's find our outliers. In this case, I'm creating a filter condition. Okay, in this case, I'm saying that any value in your CGPA column that is smaller than your lower limit, or any value in your CGPA column that is higher than your upper limit, those are my outliers. So I'm creating a mask, putting this mask inside your data frame. I'm filtering the data frame right here, and I'm printing my outliers over here. So when I run this, you can see that it prints out these outliers. In this case, you have 1, 2, 3, 4, 5 outliers right here. You can see that this value, these values, they fall outside the range of 5.11 and 8.80. They don't come in between. So these are your outliers. Okay, so in this particular case, let's change our threshold. Let's say we change our threshold to 2.6 standard deviation. In the previous case right here, I was using 3 standard deviation, right? But let's say I want to change my threshold to 2.6, and let's see what it does now. So in this case, my lower limit, lower boundary and upper boundary will change. So my lowest limit in this case is going to become 5.35, and my upper limit is going to become 8.56. So any value that do not fall in this range, they would be my outliers. So this is the same mask I just showed you. Print out my outliers again. So in this case, it comes out to be, let me run this cell first. All right, come back over here. Let's run this cell. And there you go. You can see that now you have more outliers. And that's because you have narrowed down, you have decreased this length. Okay, so this actually has decreased the size of your limit now. And because you have decreased, so now you're going to get more outliers over here. Okay, so once we have found the outliers, what next? So in this particular instance, I'm just choosing to trim. There are a lot of options available out there. I'm just choosing trimming over here in this case. Trimming is simple. Basically, you just remove those values. That's all you do. So in this case, what I'm doing, I'm saying that, hey, any value that is more than 5.11 or any value in your CGPA that is less than 8.80, I'm creating a filter for that. And then I'm putting that filter, in other words, mask into my data frame. So in this case, it prints out, it actually going to filter out only those values where CGPA is more than 5.11 and less than 8.80. Okay, and then I print out few samples just to see, and you can see that all these values now are going to be between 5.11 and between 8.80. All right, so let's verify this. Let's verify that all your values are gone. So I'm looking at my TF trim and I'm just saying that try to find any value that is less than 5.11, or try to find any value in CGPA column that is higher than 8.80 and print it out. So in this case, I'm putting that inside my DF trim and I'm trying to print my outliers. And you can see that it's empty right now. There's no more outlier left because it has removed it. Now, if you run this, if you run the shape, if you try to find the shape of your DF trim, you're going to see it is 5 less. Initially, it was 1000 rows, but now it's only 995. That's because it has removed those 5 outlier points. Okay, so let's print out this DF trim one more time. Then you can see that you have 0, 1, 2, 3, all the way up to 998. Okay, so some of the values are gone now. So now let's plot them. Okay, let's plot our value. So in this case, this is my original CGPA distribution. Let me decrease the size of the screen so it's visible. So this is my original data frame right here. This is the original CGPA, and this is the after I transformed that, after I removed this outliers, and you can see that your distribution has not changed significantly, and that's because you did not remove many outlier value. There was only 5 of them. And now we are going to be using z-score method to find outlier. And I'll show you this is essentially going to lead to the same answer. So first you calculate your mean value for your CGPA column, also calculate your standard deviation. And if you recall, the formula for your z-score is basically you're taking the x value and you minus the mean and divide by the standard deviation. This is your formula. So in this case, I'm creating a new column called CGPA z-score, and that was going to do all the computation for me. So let's run this cell and then let's print out few values. So when I print out few values, you can see that there's a CGPA, there's a marks place, and then there's a CGPA z-score for each one of them. So this z-score for 5.77 is this. Z-score for this is this. All right. So let's find any value. Okay. So in this case, I'm defining a threshold that any value that is less than -3 or plus 3, that would be my outlier, any z value. So in this case, I'm creating a mask right here. In this mask, I'm saying that CGPA z-score, that would be these values right here. Any one of these values that is smaller than -3 or greater than +3. These are my outliers. So filter that out. Print out your outliers. So when I print them out, you can see that it prints out CGPA, marks placed, CGPA z-score. So these are my outliers right here. Okay, so we see that there are 3 rows with values below the threshold, -3. You can see that this one is below -3, this is below -3, this is below -3. These are essentially the same record that I showed you on top using standard deviation. This one is greater than 3, this one is greater than 3. So now we can use a different threshold. We don't really need -3 to +3. We can actually use some other threshold. In this case, I'm using -2.6 and +2.6 as an outlier. So in this case, I'm saying that pick out the any z-score value that is smaller than -2.6 or any z-score value that is higher than 2.6. That would be my outlier. I just change the threshold, and by changing the threshold, if when I run this, you can see that your number of outliers has increased now. You can see that it has actually gone up, and that's because you have you have actually narrowed down your threshold. So now you have more outlier values in here. And now let's plot our CGPA column and also our CGPA z-score just to see how they look like next to each other. So when I run this cell, let me just decrease the size of screen so it's a little bit visible. All right. So this is my original CGPA, and this is the z-score, corresponding z-score for that. And you can see the shape essentially is exactly same. That is not that is expected. But look at the z-score right here. So any value that was outside this -3 and this 3, that was my outlier initially. Then later on, I changed it to 2.6 somewhere over here. And then you got more outlier because you have more data points over here, right here. And now I'm going to trim those outliers. That's the technique I'm using now. So in this case, I'm just going through the CGPA z-score column, and I'm saying that any value that is more than -3 and any value in CGPA z-score column that is smaller than 3. I want to keep them. I'm actually only keeping them. So that's my filter right here. And that would be my DF trim. So when I run this, it prints out my DF trim right here. So all these values have value which is between -3 and +3. In other words, if you go back to this graph, so all these values are between -3 to +3. So this was my z-score distribution. Okay, so coming back down here, so then I want to verify that my outliers are gone. So in this case, I'm just going through my z-score again. I'm just checking that no values of z-score is more than 3, or trying to find if there's any value that is less than minus 3. So I'm checking this condition just to verify that my outliers are gone, and you can see that it's empty, so there are no more outliers now. Okay, I want to see the shape. I want to know how many rows and columns I have. And you can see that now it is showing me 995 rows. Initially, if you remember, there were 1000 rows. Now it has become 5 less because it has removed those 5 outlier points. Okay, so let's print out these values. And you can see that when I print out my DF trimmed, it goes these numbers. And you can see all these values now are contained within that range now.